Have you ever wondered how machine learning algorithms classify data? Today, we'll delve into one of the most popular algorithms in machine learning, the Naïve Bayes Classifier. Imagine we're trying to classify fruits based on their sweetness. We have a table filled with data from a multitude of oranges, kiwis, and apples. We want to categorize these fruits as either sweet or not. To do this, we'll use the Naïve Bayes Classifier, a classification algorithm based on Bayes' theorem, which calculates the conditional probability of an event based on the occurrence of another event. The key assumption of the Naïve Bayes classifier is that all features are independent of each other. In our example, it means the sweetness of an apple doesn't influence that of an orange or kiwi. Now, let's move to the practical part. We convert our data into a frequency table. We count the number of each fruit and how many of them are sweet. Then, we calculate the likelihood that an orange, for example, is sweet. We do this by dividing the number of sweet oranges by the total number of sweet fruits. Next, we calculate the probability of each fruit being sweet and the probability of each fruit being an orange, a kiwi, or an apple. We then use these probabilities in Bayes' theorem to find the probability that a sweet fruit is an orange, a kiwi, or an apple. From these calculations, we conclude that oranges and kiwis are sweeter than apples. The Naïve Bayes classifier has several advantages. It's fast, easy to use, performs well in multi-class prediction when the assumption of independence holds, and it needs less training data. It's also efficient with categorical input variables. However, it's not without its downsides. For instance, it can't make a prediction if a category wasn't observed in the training data. It's also known to be a bad estimator, so the probability outputs aren't always reliable. Lastly, the assumption of independent predictors is often unrealistic in real life. In summary, the Naïve Bayes classifier, despite its limitations, is a practical tool for classifying data based on certain features. It's particularly useful when the features are independent and when you have categorical input variables. So, next time you're biting into a piece of fruit, think about how a machine learning algorithm might classify its sweetness. It's all part of the fascinating world of machine learning.